Good morning, everyone. I'm Clement. Welcome back to another episode. Today we'll be talking about decoders. Let's move straight to the drawing table. Today we'll be talking about decoders. As I mentioned earlier, we'll be talking about a 3 to 8 decoder. A decoder accepts n inputs and gives 2 to the power n output, as the same way as a multiplexer. That same formula, or in what? Base 2. Within the decoder, you will come across something as an enable line. That's the EN. The EN is not like a selector, where EN is 0, the decoder is 0. Or when EN is 1, the decoder is 1. This is because 0 multiplied by n equals 0. As we were doing the logic table for the AND gate, any number when one output is 0, the other will be 0, unless OR is 1 before the output will be 1. The same analogy implies here. So whenever EN is 0, since it's connected to all AND gates, all the circuit reads 0 output. Hope that one is understandable. Yeah. And we come back to our binary formula. 2 to the power n equals 2 to the power 3. 2 to the power 3 equals 8. Therefore, n equals 3 will be the number of selected lines we'll be using. So using the table here, come back to our 3 to 8 logic table. You see our EN here and our ABC being the selected output. Wherever EN is 0, all the circuit, everything on it will be 0. As I mentioned earlier in my presentation with the other sheet. So you see for here, there's no output showing 1. All is 0 because the enable line has been attached fully to the AND gate. So whatever happens to the enable line, that's 0, will give a 0 output. And I think that one will be clear. And whenever the EN is 1, automatically an output supposed to be 1. An output supposed to be 1. So you see here, when EN is 1, Y0 is 1. EN is 1, Y1 is 1. EN is 1, Y3. When EN is 3, Y2 is 1. When EN is 4, Y3 is 1. It follows on to Y7, as you can see here. Somebody may ask, how did you even get the values for the input? The same as the binary readings. 1 in base 2, 2 in base 2, 3 in base 2, to 7 in base 2. That's how we got our input values. 1, 1, 1 in base 2 is 7. So with this table, we can come out with our Boolean expression. This one will help us draw the circuit on the logism. So from here, we move straight to the laptop and we use the Boolean expression over here to draw. So EN has been multiplied by all the input here. See here, 0, 0, 0. It means A bar, B bar, C bar, multiplied by the EN 1. Y1, EN 0, 0, 1. So it means A bar, B bar, C. Here, 0, 1, 0. So EN A bar, B, C bar. Same as to the last one. 1, 1, 1, 1. So here will be EN A, B, C. That's how we come out with our Boolean expression. So without wasting more time, let's move to the laptop and present this Boolean expression on the laptop. Thank you. Yeah, we've represented our AND gates, 8 AND gates. That's our output with our 3 input selected lines and our enable line here. And this one, and each of them should have 2 inputs. The 0 input and the 1 input. That's A bar, and A, B bar and B, C bar and C, and our enable line. This our enable line will connect each of the AND gates straight up. We already know the number of selected inputs for each AND gate. That will be 4. So our enable line has already been connected. Each and every AND gate should be connected as such. So our enable line has already been connected to the AND gates. So from the logic table, using the Boolean expression, y0 is A bar, B bar, C bar. So where is A bar, B bar, C bar? This is A bar, B bar, C bar. So all should connect to what? Y0. This is B bar. So A bar will also be connected. And let's see if, whilst the enable line is 0, you see the output is 0. So let's enable it to be 1, and let's see the output. The output for y0 is also 1 when the enable line is what? It's 1. So whatever I explained on the sheet has been manifested here on the presentation output. So we do the same for all the other 6 outputs and see what the results. So we are moving on to y1. Y1 on with a Boolean expression says en by A bar, B and C. En by A bar. En has already been connected. A bar, A bar. This is A bar. A bar, B and C. This one is C. This one is B. So let's come down here and join them. And this one too is C. And let's give an output for this one. So our Y1 is also on. Since A bar B C and our enable line is on, our Y1 will also be on. We will do same for the others. In order not to waste time, I'll fast forward and move to the last one. So we are on the last, as I said, and these selected lines are all one, and it reads A, B, C. So we are connecting it all to the one for the input. So A, B, and C, and our light is on. So this is the diagram for 8 by 3 by 8 decoder. Our 3 by 8 decoder. We will move on. We'll say for the 16. So stay tuned for our next episode on the 16 decoder.